Hello and welcome back to the WSMX programming training. Here in this lab recording, we are talking about lab number 2, task 3, or in short, task 2.3. And this one is about understanding the test method code of the distortion AC.java test method. So, as the first step is we're gonna open the test method and then locate the instantiation of the test descriptors, of the eye measurement object, of the input parameters, and also the test execution. So, for that, let's put that aside and jump right into the running smart test session. I'm here in the package explorer in the WSMX_lab file and source folder under distortion AC. You have here the distortion AC.java. That one is that one here. And if you scroll up, that you will see here the instantiation of the measurement object. You can see here then the next 4 lines are for the parametric test descriptors. If you want to have more information of what this is, you can uh, actually hover with your mouse over it, and then you will get some more information here. You can do the same with the parametric test descriptor. And then even here you can click into it and scroll down to get more information. Also here are some numbers for topics in the Advanced Technical Documentation Center for SmartTest 8. So if you just copy paste this number here, for example, and then you go into the TDC and you put it in here and hit enter, then you have here a description of what is. Okay, so I mean, going into detail for that one here is beyond the scope of this lab recording, but just that you know. Okay, so we have here instantiated 4 different parametric test descriptors, and we named them PDT, THD, and so on. We will come back to what those names mean actually a little bit later. Here we defined the input parameters. So we have an input parameter for a string as DGT action and signal and those things. We will come back to that one later as well when we are then setting up the distortion subflow. Yes, and down here we have the measurement execution. So we're just executing the measurement, but nothing else. So now we go back to the lab manual, and here we have to supplement the test method with the following sections of code. First, we have to actually add something for the result retrieval and to release the tester. So I'm gonna put that aside here. And below the measurement execution here, we're now gonna add the one for the digitizer. Please remember to use the content assist, so control space, and then that one pops up here, and it's already giving us the iDigital results. We're gonna call that my results, right? And then this is the measurement object, and then digitizer function of it. Here we go. And here we actually have the DGT signal. Here you can also use content assist, and then we're gonna preserve the results. So by that we tell SmartTest that everything, all the results of a digitizer instrument of this associated with this measurement object in this test suite here should be preserved such that we can access them later. Now we're gonna add the release tester line. Release tester means that now everything below that one is actually done as in the background, and we are already releasing the tester hardware such that it can continue um, setting up a new measurement, for example in a new test suite or those things. But we will not lose our results since we added this line of code here. Okay, then with the get waveform method, we're gonna retrieve the captured waveform of the measure waveform action. So now we are here at step number 4, and we're gonna add this line here. So here we just go and we start with a multi-site wave double. That's that one here, right? We're gonna call it result waveform, and that is actually our my results variable here, and gonna use the measure waveform action. It's gonna be applied on the DGT action here, so that's already like Smart is already providing this option. Gonna get waveform um, on the DGT signal. Why don't we get that one here? Signal and get element 0, since we only have yeah, maybe at that point it makes sense to go to our operating sequence. So that is the operating sequence here. Let's move that over here. And we only have one uh, measure waveform action here. So it's called measure wave sign, but in the specification file here, you see that this is a measure waveform, and that exactly is what we put into here. And then we can specify the name of this measure waveform action. And with the get waveform, actually, we are retrieving all site-specific values of the specified signal from all active sites. Okay, that's not very specific, but you could also then, for example, click in here, and if this is not enough information, you could either go to the TDC, or another trick is that you click on that one and then you press F3, and then you see actually that here in the Package Explorer, we are now in the device test environment. So that's kind of a library provided by Advantest if you're using SmartTest. That's by default included. And then we have here the result waveform class. And then you see here actually that uh, what is done here for the get waveform. And then sometimes you have some more information here. But usually you should not change any code here in the device test environment. So you as a user, you're only supposed to work with what's here in the source folder. Under no circumstances you should change anything here in the device test environment or in the JRE system library. Okay, so let's close that one again and go back to our testmaster code. Next line here is that we should actually add the line for the offline result emulation. Let's do this one here. So here we now have the result waveform. Result waveform is util waveform.ore. It's already providing that one. Result waveform log level 0 and context. So that is basically what we need. So with that, we are actually telling SmartTest, okay, now we have this multi-site wave double um, variable, and you should actually add the measurements of the measure waveform action into it. But since we're in an offline session, in this line here, we're telling SmartTest to fill that variable here with some offline result emulation. Okay. Then next line is add the line to plot the waveform into the signal analyzer. That's step number 6. So we are now here. Whoops. Very good. Next step is to um, actually define our multi-site spectrum. Result waveform dot spectrum, and then we have to specify the units actually, spectrum unit, and then we have, if you hit the dot, we have several different options here, and for that one we gonna use actually the milliwatts. Okay, then we are here already at step number 8, set periods, num cycles, which is required to calculate the fundamental frequency, should be 0 by default if the waveform is not a sinusoidal. Well, here we are having a sinusoidal, so it doesn't really matter, but let's do it anyway. Set periods, num cycles, also have that one here. Very good. Num cycles is one of the integers we have defined here, and which will be passed on from the distortion subflow, which we're gonna set up later. Okay, and then step number 9, compute and evaluate the power of the fundamental, the harmonics, the signal to noise ratio, the signal to noise distortion ratio by using the respective methods of the multi-site spectrum object. Yes, that's we're gonna do now. And for that, we have first here our parametric test descriptors. Let's first take the signal power, evaluate. It's gonna like force a pass fail decision, and here we gonna say it should take the result spectrum variable, and then we can just use the fundamental method of this multi-site spectrum class to do this. So that is, whoops, no, that was a typo. Yeah, already here. Yes. Let's first complete this with the other ones. So we have here the third harmonic distortion, evaluate, and we have again the result spectrum, and now the THD function or method. Next is the signal to noise ratio. Result spectrum, and then we have the signal to noise ratio function of the multi-site spectrum class. Whoops, typo. Here we go. And then also we go to the signal with the SND. Evaluate. So I think that is now very convenient, because here those built-in methods for this multi-site spectrum object are already provided in the device test environment here, so we don't have to write any code if we want to use that one. If you want to have more information on that one, just click on it, press F3. Then in the package explorer, you're now here in the device test environment. We are now here in the multi-site spectrum class, and you see here fundamental power, and then it gives you a description of what this actually does. You can do the same for all the other things we have here. So for example, here we have now the signal to noise and distortion ratio, SND or CNOT. It's also telling you in which dimension this is, in which units, and here you get some more information on that one. So that is very helpful, and with that you can actually write a lot of test method code very fast and save a lot of coding lines and coding time. Okay, let's go back to the distortion test method code, and I think the last task here, or the last step, is actually to add this code snippet here to plot our multi-site spectrum into the signal analyzer tool such that we can actually visualize it and play around with it. For that we have the, whoops, we have if, and then the plot graphs, which we actually retrieved before. Here we go. And the result waveform dot spectrum. Oh, come on. Here it's important to say that we actually want to have a spectrum scale logarithmically, and here also what we do with that one, scale of the spectrum, they give us more, 1.0. Spectrum dB, that's gonna be the name we will see in the signal analyzer tool for that one here. And with that we also added the last line of code. If you're interested what those input parameters mean, you just hover over the plot one, and then you can go down here, and then for example this true means that we enable the site overlay. Spectrum scale, okay, here actually not so much information is given. Here, that's where we are. Okay, so you see that here you get also a lot of information, and here we would set actually the reference level of our logarithmic plot here to 1. Okay, and I think I don't see any error highlighting here in the test method code. Oops. Let's just format that one, save it, and then this is our test method code. Okay, so this was task number 3, and in the next video we will continue with task number 4. Bye bye.